Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the equilibrium constant. It's very important to understand what the equilibrium constant means so that way you can interpret how to solve different problems involving your equilibrium constant. And so in this video and the next several videos, I'm going to be going over how to understand the equilibrium constant as well as how to interpret it in the context of certain problems, whether you have a small k or a large k or k equal to 1 or approximately equal to 1. It's very important to take that in consideration as well as whether or not it's shifting right or shifting left, so that way you can set up your problem to more easily solve it. So let's get into this. So first I'm going to go over how to understand what k is and what a large or small k means. So first of all, here you have your generic equilibrium reaction. It's in equilibrium because you have the double arrows. Whenever you have double arrows, that means you have an equilibrium situation going on where the rate of the forward reaction is equal to the rate of the reverse reaction. And that is what we mean by equilibrium. So when we talk about equilibrium and we talk about K comes from what is called the law of mass action, meaning that the concentrations of products and reactants are going to influence the rates of the reactions, right? You're going to influence your equilibrium. So that's what this is referring to here. And so KEQ, or what is often called K, right? So I'm going to go back and forth between K and KEQ. KEQ means the equilibrium constant for a particular reaction. Now, K is more of a generic reference of equilibrium because you can have very different equilibriums in different situations. For example, if you might know of something called the Ka or the Kb. Those are equilibrium constants that are involving acids or bases. So Ka is the equilibrium constant for a dissociation of an acid in water. Your Kb is going to be the equilibrium constant related to a base dissociated in water. And so we give different uh, symbolism for different K values. And so I go over that in other videos. So here we call this KEQ, which is going to be the generic equilibrium constant for a reaction that isn't a base or an acid or something like that. So what we understand as KEQ is this form right here, this expression of KEQ. So this is our generic, uh, our reaction where we have A and B for reactants and C and D for products. Then the KEQ or the equilibrium constant for this reaction is just going to be the concentration of your product C raised to the power of its coefficient, little c here. And then that's multiplied by the concentration of D, the other product, raised to the power of its coefficient. And then you divide that by the concentration of the reactant A raised to its coefficient, little a. And then that's also multiplied by the concentration of the other reactant B raised to its coefficient, power of B, right? So this is generally or generically what your K expression is. And so if you have more reactants, then you're going to have more concentration of reactants raised to their respective coefficients as powers. Or if I had another product, then I would multiply that by that product. If I had a product E raised to the with the E coefficient, then I would have multiply that by the concentration of E here raised to the coefficient of E raised to the power of E, so on and so forth. So generically, or very generally, basically what KEQ is the ratio of the products over the ratio of the reactants. So you can kind of more generally think of it that way. In a more simplistic way, that might be helpful to see or understand what's going on when we have a large or small K value. So let's talk about K as large, small, or close to 1. So when we understand KEQ as a ratio of products and over reactants, then when we have a very large K value, that means that you have a lot of product that is a large numerator, right? So there are numerators products. So that means your products are large and you have very little reactant, or you have a small denominator. So the denominator here is very small relative to the amount of products. That is what is giving you a large K value. So for example, in this reaction here, we have your silver ion aqueous reacting with aqueous ammonia to form your silver ammonia complex ion here. And so we have an equilibrium reaction here, and it's very large. The KEQ for this is 1.6 times 10 to the 7. So this is a very large K value for this reaction. What does that mean? It means that you have a lot of product compared to reactant. So basically, when this reaction is at equilibrium, you're going to end up with a whole lot of product on this side and very little of reactant on this side. So you're going to have a tiny amount of this in solution and a tiny amount of this in solution compared to a whole lot of this in solution at equilibrium. Okay, so that's what the KEQ means here for this reaction. This is very large, so we have a lot of products at equilibrium and very tiny reactants at equilibrium. Well, what about K is small? Well, K is small, again, if we're thinking about the ratio here, if this K value is small, that means the ratio is very small, which means that we have a lot of reactant here on the bottom, the denominator, right? And a little amount of reactant or product in the numerator here. So lots of reactant, large denominator, and very little product, small numerator. So to use an example again, we have 2NOCl gas is in equilibrium with 2NO gas plus chlorine gas. And so when this reaction is at equilibrium, if you look at the KEQ value, it's 1.6 times 10 to the negative 5. So this is really small. So that is, again, saying we have a large amount of reactant and a very small amount of product at equilibrium. So we're going to have a whole lot of this in equilibrium, and we're going to have a tiny amount of NO and a tiny amount of chlorine at equilibrium. And so that's what a small KEQ means for the reaction. Now, finally, what if we have a K that's not quite large and not quite small? Maybe it's approximately 1, right? So what does that mean? That means that the numerator and the denominator are approximately equal. So this bottom part here is approximately equal to the top part here. And so what that means is that you're going to have about equal amounts of each. And so you're going to have, in this example here, we have N2O4 gas in equilibrium with 2NO2 gas. So the amount of NO2 gas on this side is going to be approximately equal to this side, because if you notice, the KEQ is 0.133. And so since 0.133 is kind of close to 1, then that kind of gives you an idea that these are going to be kind of equal to each other. Okay, so that's it for understanding what the K value means, where K comes from, what the equilibrium constant means, what it means when it's large, when it means it's small, when it means it's equal to 1. So in other videos, I'm going to show you in specific circumstances how you can use your understanding of K to help you solve interesting problems, especially when K is very large or K is very small. If it's shifting left or shifting right in whatever circumstance, how can you understand this circumstance to help you solve the problem in the easiest way possible to avoid these really ugly quadratic formulas, or x to the third power or x to the fourth, where really you can't solve it unless you do a lot of math, or if you have a computer calculator that you use. We want to avoid all that. And so in the next few videos, I'm going to show you how you can avoid all that and simplify the problem by being able to neglect your change in x and all of that. So stay tuned. And until then, please, by all means, if you like this video, if you learned something from this video, please hit that like button, share it with your friends. Also, make sure you subscribe to my channel, hit that notification bell so you can be notified by all the videos I put out. Maybe make sure you click all. And finally, put a comment down below. Let me know if you have any questions. What are your thoughts? I'd love to hear from you. Thanks for joining me, and have a great day.